Hi, welcome to lesson 14.2, the axis of symmetry and the vertex. It's actually a little vertex formula that we're going to go over again today. So first we're going to learn to identify the axis of symmetry of the graph of a quadratic and then identify the vertex of the graph of a quadratic. So as we talked about before, the axis of symmetry of the parabola is determined by the function. It's y equals ax squared plus bx plus c. So if it's in standard form, it's the vertical line that passes through the vertex. And there's a neat little equation that we use. It is x equals negative b over 2a, which hopefully you recognize a little bit of that from maybe the quadratic formula. So the vertex is on the axis of symmetry, and the x-coordinate of the vertex would be that negative b over 2a that we find. So let's take a look at the graph they have here. It says each point on a quadratic graph will have a mirror image point with the same y-coordinate that is equidistant from the axis of symmetry. For example, 0, 5, which we can see right here, is reflected over the axis of symmetry to the point 6, 5. So it's got a buddy on the other side. Okay. Now, question 1 says, give the coordinates of 2 additional points that are reflections over the axis of symmetry. I can see the intercepts, actually, the x-intercepts. I see one at 1, 0 and at 5, 0. They are equidistant from that line of symmetry. For each function, identify the zeros graphically. Okay, so the zeros of a function, of course, are the x-intercepts. So I see negative 4 and 2. Okay, so the zeros are negative 4 and 2. Okay, and then it says confirm your answer by setting your function equal to 0 and solve by factoring. So if I let 0 equal x squared plus 2x minus 8, and I factor it, x and x, and then I need two numbers that multiply to negative 8, but add to 2. So that should be 4 and negative 2. And if you set both of those equal to 0, we should get those intercepts that we saw before. So x equals negative 4, x equals positive 2. Those are our zeros. Now let's try it on the second graph. So on the second graph, we have zeros at, looks like negative 1 and positive 5. So let's go ahead and change this one to 0 equals. And for this one, I'm going to have to factor out a negative, I believe, to make it easier to factor. So then we'll have x squared minus 4x minus 5. So we get factors of x minus 5 times x plus 1. Okay, which gives us that negative 4 in the middle now. So now when we set our factors equal to 0, x minus 5 equals 0, and x plus 1 equals 0, we can see we get that 5 and that negative 1. Okay, so we can get those zeros from the graph or from the factors. Okay. So now, for each graph in item 2, we want to determine the x-coordinate of the vertex by finding the x-coordinate exactly in the middle of the other two zeros. Okay, well, the x-coordinate of the vertex should be on the line of symmetry. So if we look at that line of symmetry that goes through the vertex, like that x value is at negative 1. Okay, so for the first one, that x value that's in between those zeros is negative 1. Now let's check that with negative b over 2a. So negative 2 over 2 times 1 gives you negative 2 over 2, which is negative 1. So that formula will also get you those that vertex in that line of symmetry. And let's check part B. Now this time the line of symmetry is going through the x equals 2. Okay, so we should get a vertex of x equals 2. So let's do our negative b, so negative 4 over 2a, which is 2 times negative 1. So negative 4 over 2, and we get, negative 4 over negative 2, because that's a negative 1 for a, and that gives us positive 2. So we do get negative b over 2a to help us get the vertex. Okay, well, once you get the x value of the vertex, you can get the y coordinate now just by plugging it back into the function. So to find y for part A, I'm going to put negative 1 squared plus 2 times negative 1 minus 8, which is 1 minus 2 minus 8, which is negative 1 minus 8, which is negative 9. So the y value of the vertex, as we can see in part A, is down here at negative 9. And for part B, we are going to do the same thing, but this time we got a 2. So y equals negative 2 squared plus 4 times 2 plus 5. So that's negative 4 plus 8 plus 5, or 4 plus 5, which is positive 9. So this time we can see that the vertex is up here at positive 9. All right, so now we actually have the vertex for each one of these. So for part A, we have the vertex, and we've got it as negative 1, negative 9. And since this graph is going up, it's an upward facing graph, that negative 9, that's going to be considered a minimum. And since we have in the second graph a vertex of 2, 9, and this time the graph is upside down, that 9 is going to be a maximum or a high point of the graph. So where the x value is going to be your line of symmetry, your y value is going to be your minimum or your maximum for the graph. So we'll spend a lot more time practicing graphing and doing some of the check your understandings. We'll work on these in class. Well, thanks everybody. Have a great day.